Hey, Mr. Simon here. We're going to look at a couple of method and control structure FRQs from the last couple of years. And let's start with the frog simulation. This is from the 2018 exam. This was the first question, first FRQ. And I actually got to grade this. So I was in Kansas City, and so I know, I saw a lot of the mistakes that people make with this. So in the frog simulation, you're simulating a frog that jumps. It has a goal that it needs to reach, or it should reach, and a maximum number of hops to reach that goal. Now, it's not always going to make it. Sometimes it'll make it, sometimes it won't. With each hop, we need to check to see if the frog reached the goal. Now, if its position is equal to the goal, that counts as a success. And we say the frog made the goal. If the frog takes a negative jump, which it might do, and it ever goes behind zero to a negative position, that's a failure. And it's okay if it's equal to zero, but less than zero, we call that a failure. And if the frog took the maximum number of hops and didn't reach the goal, well, that also counts as a failure. So here's a picture to kind of help you think about it. Frog starts at zero. Let's say our maximum number of hops are 3. The frog goes 1, 2, 3. Well, it didn't reach the goal. That counts as a failure, so we'd return false. Or if, let's say, the frog starts at 0, and on the first jump it goes here, second jump goes negative past 0 in the wrong direction, well, that's another failure. The one that really tricked people a lot is this one. Let's say the frog goes 1, takes a nice big jump, 2, and then on the third jump it would come back negative back here. Well, that should be a success. So with each hop, you should check after 1 hop, did it reach the goal? After 2 hops, did it reach the goal? Yes, right? Then you would return true, and don't let it take that third hop. So even though there's a max hops variable, we might end the simulation early if the frog goes negative, or it reaches or passes the goal distance. Now, you don't have to worry about any random numbers here. Another common mistake was people would start to write code using math.random. You're not going to do that because there's already a function called hop distance. It's a helper function that's been written for you. So you're going to use hop distance. And in fact, if you don't use hop distance, you're not going to get full credit for the problem. So it's going to be something like this. You're going to be keeping track of the hops, keeping track of the position of the frog, making sure you don't take too many hops, because you always want to look at that max hops variable, and then you always want to call that hop distance. And then you're going to check to see where the frog is and see if it was successful or not, and return a true or a false. Now, the second part asks you to run some number of simulations, right? So we're going to have an argument here, and then we're going to run that many simulations. Now, we have to call that simulate function that we wrote in part A if we want to get full credit, probably much credit for this assignment. So let's say we have 400. Then we're going to call the simulation function 400 times, and we're going to count the number of trues. And then we're going to return the number of trues divided by 400. So be careful here. We need to return a double. Num is an int, and it's very easy to count the number of trues as an int as well. So you're probably going to need to do some casting to make sure you get a good decimal number to return. Now, this is a really mathy one. This is from last year's. This is 2019 A1, and this is APCalendar. And we're going to be calculating the day of the week based on things like leap years and the month day of the year that we want to find. This would be a hard math problem, but they give you some super useful helper functions. In part A, is leap year is going to make it all real easy for you to figure out whether or not it's a leap year, so you don't have to worry about that. And in part B, which we'll look at in more detail here in a second, first day of year and day of year return numbers to represent days of the week like Monday, Tuesday, and Wednesday. So you're going to need to use all 3 of these helper functions. Is leap year in part A, and first day of year and day of year in part B. Make sure you use those, and this is a common thing in the AP exam. If you don't use the helper functions that they give you, you're not going to get full credit. So part B is really the tricky one. So let's use this year as an example. January 1st of this year, 2020, was a Friday. So first day of year 2020, this is a helper function, so it's already been written, is going to give us 5. That's because we start counting the days of the week with Sunday at 0, Monday at 1, Tuesday at 2, and so on, and Friday is a 5. Now, January 10th of this year was the 10th day of the year. So if you start counting at 1, start counting at 1 for January 1st, and then you go up to 10, you're going to count 10. 1, 2, 3, 4, 5, all the way up to 10. Now, you might notice when we're counting, or when we're numbering the days of the week, we start with Sunday at 0. When we're counting how many days of the year there have been, we start counting from 1. So already we're off between these two. Now, both of these, day of year and first day of year, are helper functions. You're going to write day of week. Now, as an example, since January 10 was a Sunday, if we called day of week for January 10th, 2020, it would return 0 because Sunday is a 0. So you're going to write code like this. There's not a lot of code, but it's pretty mathy. You're going to figure out what number was the first day of the year. Remember, for this year, 2020, the first day of the year was a Friday, so this would be a 5. And then we're trying to figure out what day of the week it was for this month, date, and year. Well, day of year will give us a number like 10, right? If this was January 10th, 2020, N would be 10. And we want to get an answer of 0 because the correct answer is Sunday, which is the 0th day of the year. So you're going to need to write some sort of arithmetic expression here involving the number for the first day of the year, the number for the day of the year that we're trying to figure out, month, day, year. It's probably going to involve modulus, right? Because the days of the week return to 0 on every Sunday. So we've got 7 days of the week. Probably going to be some modulus in there and some sort of adjustment because when we're counting days of the week, we're starting at 0. And when we're counting how many days there have been in the year as the nth number of days, we start counting from 1. So you're going to have to figure that out. But remember, good news is there's always partial credit, and there are really very few 100% correct responses on FRQs. So, if you're getting 70, 75%, you're well on your way to a 5. So anyway, good luck. Let me know if you got any questions, and thank you for watching.